So we have this analysis problem. We have two real valued functions f and g, and we want to prove that the integral of f, where the bounds of integration is from 0 to x, that quantity squared, minus the integral from 0 to x g, this quantity squared, is bounded by x times f minus g, L2 norm of that, times the L2 norm of f plus g, where t belongs to the domain 0x and x is strictly bigger than 0. So we start from this quantity with the integrals inside. That is the difference between the two squares, so we can use the identity integral 0x f dt minus integral 0x g dt times integral 0x f dt plus integral 0x g dt. We can polish this part here. It's going to be the integral from 0 to x f minus g dt times the integral 0x f plus g dt. We can break the absolute value into the product of two absolute values. Integral 0x f minus g dt times the integral 0x f plus g dt. So we can bound this. It's going to be the integral from 0 to x f minus g dt in modulus times the integral from 0 to x f plus g dt, absolute value of that. And now we can use the Schwarz inequality. For each one of the integrals. So that's going to be the integral 0x dt to the power of a half, integral 0x f minus g squared dt to the power of a half, times the integral 0x dt to the power of a half, times the integral 0x f plus g dt. So that in raised to the power of 2 to the power of a half. That integral is from 0x dt is x, and then that's going to be x to the power of a half times the integral from 0 to x f minus g in modulus in absolute value dt f minus g in absolute value squared, that integral, that raised to the power of a half, times x to the power of a half integral 0x f plus g squared dt to the power of a half. That's gonna be x in absolute value, but we know that x in absolute value is gonna be x. That's going to be x, as x is bigger than 0, so we can remove the absolute value, times the integral from 0 to x f minus g squared dt to the power of a half, the integral from 0 to x f plus g squared dt to the power of a half. So that's going to be x times f minus g norm in L2 times f plus g norm in L2 0x. So at the end of the day we have integral 0x f dt squared minus integral 0x g dt, and that to the power of 2 is bounded by x times the norm of f minus g in L2 0x times the norm of f plus g in L2 0x, and that concludes the proof.